Car A moves along a straight path with the initial velocity of 15 meters per second at the acceleration given by 5 minus 2t meter per second squared, where t is in second. While car B, which is 100 meters ahead of car A, starts moving from rest along the same straight path at the constant acceleration of 10 meters per second. If both cars start at the same time and move in the same direction, sketch a schematic representation of the above problem. Determine whether car A will eventually overtake car B or not. If yes, at what position and time? If no, determine the position of each car when t equal to 5 seconds. Determine the relative velocity between the two cars at the instant when car A overtakes car B or when t equal to 5 seconds. So let's say that we have this line. So we have car A, this is point O. We have car B, this is B. And this one has a velocity of VA, with VA initially is 15. VB, the velocity VB naught is 0. It means no velocity there. The distance here is 100 initially at t equal to 5 seconds. Before that, let's write the kinematic equation. The equation about the position, the velocity, and the acceleration. Let's start with point A. With point A, we have A is 5 minus 2t meter per second square dv over dt. So I can obtain velocity by integrating this equation one time. So I have 5t minus t squared plus v naught. Replace v naught with 15. So I erase this one, I replace with 15, the unit meter per second. This v is dx over dt. So I can obtain x, 5 over 2 t squared minus t squared over 3 plus 15 t plus, don't forget, x naught. But x naught, the position of car A initially is 0. We have x naught is 0 position at t equal to 0. So it means this is 0, so I can erase. So these are the kinematic equation of car A. Car B, which is 100 meters ahead of car A, start moving from the rest along the same straight path at the constant acceleration of 10 meters per second. So A is 10 meters per second square. This is dv over dt. It means v equal to 10 t plus v naught. However, v naught, according to the problem, is 0. V naught is cancelled. And then this 1 is equal to dx over dt. So you have x equal to 10 over 2 t squared plus x naught. X naught, according to the problem, is 100 meters in front. X b naught equal to 100 I meter. I have x naught equal to 100. So I replace this one with 100. So I replace this one with 5. 5t squared plus 100 meter, and that is point B. So you have the kinematic equations for car B. You have car A and car B. Here, if you see the equation of acceleration of car A, 5 minus 2t, car A, If t is increasing, acceleration decrease until a certain time it starts to become negative. When acceleration is negative, it decelerates, it becomes slower. So there is no possibility for car A to overtake car B because B is faster, A becomes slower. The position at t equal to 5 seconds. xa 5 over 2 t squared minus t cubed over 3 plus 15t. You replace t with 5, you are going to have 15 meter per second. Velocity, VA, 15 meter per second. And VB is 50 meter per second. You see, VB after 5 seconds, VB is much faster than VA. XA equal to 95.8 meter. You just put 5 seconds in the equation, and XB equal to 225 meter per second, much further away from point A. Determine the relative velocity between the two cars at the instant when car A overtakes car B, or when t equal to 5. A never overtakes, so when t equal to 5, the velocity of A is this one, B is this one, B relative to A is 35. According to car A, velocity B is 35. The velocity of A relative to B, it will be negative 35. That is 50 minus 15. If you want to make it vector, you write correctly, this is I, all I, huh? Because everything is I. So this one is I, all I. You can omit I because everything is in I direction. You can also write VB relative to A is 35 meter per second directed to the right. And VA relative to B is negative 35 meter per second directed. Sorry, no need to put negative, but you put the arrow to the left.